Hello everyone, welcome to Liquibase Demo. Let's see Liquibase in action. First we'll go through the repository structure. In this I've created certain directories for my own use, like functions, packages, procedures, sequence, so that I can place the script files which are affecting any of these objects in their corresponding directories. This is not specific to Liquibase, this is just something which a structure which I'm following for this demo. So the Liquibase properties file is the file which gets read first when we is the file which gets read when Liquibase gets executed every single time. What details it has? It has the database specific details, first of all, like driver and class path, so it understands what kind of database it is dealing with, and then the URL. So you mentioned the database which it has to connect to, so that is the database URL that we give, and then the credentials for the schema and the changelog file. So structure we are following here for the changelog files is such that there will be one master changelog file which will refer to multiple child changelog files. So the master changelog file will have all the changes listed in it since the Liquibase, since we started using Liquibase on a regular database. So all the changes that has happened on a database, if you want to see what all changes, what all scripts were executed, we can just have a look at the master changelog file and and understand what all changes have been done over the period of time. We are not going to have a look at the reference parameters for now. For now it is just enough to know that this will be used for the diff functionality of Liquibase. Let's go through the master changelog file. So to begin with, we are just going to execute two files. So we included two files here. One is the baseline file, the SQL file, and one is the changelog 100.xml. This will apply all the changes on the database that we intend to. What baseline file or the baseline SQL does is it establishes the baseline version for the database, for the Liquibase. Since before this execution, we did not use Liquibase on this database. So whenever we start using Liquibase, it is a good practice to tag it with the baseline version. So Liquibase understands that all the changes from here on are performed using Liquibase, and any other changes which are older to this were not using Liquibase. How Liquibase understands this is it reads the first line, that is Liquibase for auto SQL, so it understands that it expects that it has all the attributes or the tags that it requires to log it into database change log table in this file. For change set, it has ID and author. So it's author and ID. So tag is the author and baseline. Tag is the author and baseline is the ID of the database change log table, which goes into the database change log table. What we do as part of update statement is that we update the database change log table and assign the value of baseline to tag field, and we give the rollback statement here. So in case we want to roll this change back, this is a statement which gets executed. So this will basically remove the baseline entry from the database change log table. The other file, which is dbchangelog100xml, this includes three files. One is for creating table, one is for creating sequences, and one is for inserting data into tables we just created. So let's quickly go through these three files. For table creation, we have the sequels for creating tables, departments, and employees. There is no change or there is no change in the format, or there is no different format which we have to follow for Liquibase. So SQL syntax remains the same. Apart from that, since we have mentioned it is a Liquibase formatted SQL, so Liquibase expects again certain things from this SQL, like a change set details at least, and the rollback information. So we have change set information is author is my ID, it's Yusha, and we have the ID as 001. That is the version that we are marking this SQL script as, and we have 002 for creating employees. So we incremented the version by 1 here. There are preconditions, that is a change in this changelog file as compared to other changelog files that we saw before. So this precondition, what it tells Liquibase is that if the precondition fails or it errors out, halt the execution, do not move further. What is the precondition we are looking at here is SQL check precondition. It has attribute expected result, so it can be any value, numeric value. Here we have mentioned 0, so the SQL that follows should return 0 in order for this change to be executed. So we are just verifying that departments table does not exist already. If it does, halt the execution. Similar check is for employees, and we have rollback statement which says drop table departments and drop table employees. Let's go through the sequence which is the next in order to be executed. So we are creating sequences and we are dropping the sequences as part of rollback. And we have the IDs incremented by 1, 0. So it's 003 and 004. Let's go through the data that we are going to insert. So we don't have any preconditions here. The change set has been the ID for the change set has been encrypted by 1 each time, so 5 and 6. What we are inserting into departments, we are inserting 3 departments: technology, research, and marketing. We are using sequence for each of them, which we went through in the previous file. We have created employee sequence also for employees table, so that is what we are using for inserting data into employees. Sheldon Cooper and Amy Fowler are working in technology department. Tony Stark and Cosmo Kramer are working in research, and Don Tripper works in marketing. So you have some interesting employees here. So that's pretty much about it. And we are deleting the rollback again inclusive statement for this data. So that's pretty much about. So it's pretty much the same format, like we mentioned that this is Liquibase formatted SQL. It has some change sets in details, and then preconditions, and then rollback. So this is the overall format of a typical change log. Let's make sure that in the master change log we have only 2 SQLs mentioned and not more than that. Yes, 1 SQL and 1 XML. This is good. So it should, when we run this, it should execute the first SQL and insert the entry for baseline and then execute all the changes. Let's look at the database before we execute Liquibase. So database changelog table does not exist, and user tables does not have any tables. So there's particularly, this is a clean database. There are no objects in this database. Let's go ahead and execute. So how we apply changes is we say Liquibase and then update. Says update is successful. Let's verify. Yep. So first entry is the baseline. So ID is the baseline and tag is the author. It tells you which file it executed. Actually, it gives you the file along with the entire path. It is with respect to the changelog. And the checksum is basically calculated based on ID, author, and file name. It says executed for all of them, so this is the order exactly in which we mentioned the changes, and it has been executed in the same order. And we are using Liquibase version 3.4.1. So all this information, if you see, like it executed tables and then sequences and then it inserted data. So we know exactly which SQL got executed as part of this Liquibase execution. So it really becomes very helpful while auditing anything or while rolling back. So whenever we want to roll back, we can make sure that yes, what changes are going to be rolled back. What we'll do next is we'll just verify, like yes, we can see all this here, but are the tables really created? So let's verify that. Yes, so it creates this two tables, database change log and database change log. So these are the tables which are uh, which Liquibase uses to audit and maintain and track all the changes. Departments table has been created. Let's verify if insert worked successfully. Yes, it did. And we see the sequence value is also here, but we'll still go ahead and verify. Let's look at the employees table. And the sequences. So sequences are created. So all the changes which we give input to Liquibase have been executed. What we'll do next is let's see one of the modes of the rollback. So there is a rollback count command which rolls back each change. So if we give a number, let's say if we give number, we have 7 changes here. So if we give number 7, it should roll back everything. Let's see if that happens or not. So for that we have rollback count attribute, which we give input 7 to. So let's see. Yeah, all the changes have been rolled back. We'll again see if it has actually been rolled back. Sequences are gone. Yes, so only database change log and log table remain. Rest all the tables have been dropped. So this is good. What we'll do now is let's bring all the tables back again. So we just say Liquibase update and all the changes. Let's assume that we had made some changes to the script. Scripts didn't work fine the first time. Made the changes, we execute Liquibase update again. It should bring back all the tables. Yes, it did. Okay, so this is good. Now going for after this we determine that yes, these changes are good, QA cleared it, everything fine. Now we'll tag this, that it's time to tag this changes. So what we'll do is we'll have an update script similar to baseline. We'll have dbtag100.sql. So what this will do is it will again have the author as tag and id as 100 here. So we are tagging this all the changes as 100. We also update the tag value to 100. Similarly, we have a rollback statement for it. So this is a SQL. So let's include this SQL in the master changelog because that's where all the changes are. So okay, we are not going to remove the old change sets which we already executed, since Liquibase will internally determine whether those were executed successfully or not, and if it needs to re-execute those change sets. So that's something which Liquibase determines on its own. We don't need to make any changes to the old change sets. Yep, it created a new tag. What it did was the previous SQL which we executed, it has marked that as 100 in the tag column, and it created a new entry, and it also mentions which file it executed for that. So this is good. We tagged it. Now we move to the next sprint. We again take in more changes. The new requirement is to create an Oracle database package. So we will let's say we create a different version for it, v110. In this we have a child changelog which will be ultimately referred by the master changelog. So in this we mention the SQL file, the XML file in fact, which will help us in creating the package. Let's go to that SQL file. So for creating package, Liquibase does not have its own refactoring refactoring attribute. So that it has a SQL file tag. What the SQL file does is, like, in Liquibase we normally use the SQL file when we have to refer to an external file, which, so external file is something which is database specific, which is not database independent. So since Liquibase does not support right now at this point creating package, so we refer any function which is not supported by Liquibase, we can accomplish or we can achieve that using external files. So we have a SQL file for that. So we have the, let's just go through the SQL file first, and then we'll come back again. So it's a typical SQL file. You will notice here that it does not have Liquibase format SQL tag on the top of it. So this is specific to the database. Here you mentioned Go. This indicates the end of a particular SQL execution or a particular SQL, like where it ends. This is the delimiter for that, and where the new SQL starts. So this is what we have specified. If you notice here, we have specified that Go is the keyword which are going to use as a delimiter for multiple SQLs, and here is the path of that SQL. So this is a typical normal Oracle SQL. There's no syntax change or anything. This is database specific. And this parameter just informs Liquibase that this path is relative to changelog file, so it is in the same directory as the XML file. So this SQL is in the same as this XML file. The one very critical and very important attribute to this change set is run on change. So run on change, when set it to true, what it does is every single time Liquibase runs it checks if there is any change in the change set. So in this case, the underlying SQL, if it has changed, it will re-execute that SQL. Since procedures, functions, packages are the objects which change very frequently, and this parameter comes in very handy. We don't need to create a new change set for it. We can modify the existing change set, and Liquibase will take care of it on its own. We don't need to specify anything new here. We don't need to create a new entry in master changelog file. Nowhere we need to create any change. So simply go to the existing change set which we used for the package, modify it, and Liquibase will take care of it. We'll see how it works. First, what we'll do is, like, we'll create the package, and in order to do that, let's comment out this, and then we'll include this later to check the run on change. Okay, we have made that change. Let's make sure this changelog is there in master changelog file. Okay, so we include that XML, and let's execute this update. Let's see what is in the changelog. It says it executed the package. Let's that. Yes, it does, and the function is commented out. LM function is commented out, and let's look whether the body is included. Yes, it has. Okay, so this is how the packages, processes, and functions are created using Liquibase. Now what we'll do is, like, we'll go ahead and make the change. We'll uncomment this function in the SQL that we created. So we'll not do anything else. We'll just go to SQL. We'll we uncommented this and go to the command line, execute that again. Let's verify the changelog. It says rerun now, so it says that it did run the changes again. Let's see if it has applied the changes. Yes, it does. So lm is uncommented, and then we see in the specification also. So this is where run on change comes really handy for all these objects which change very frequently. This is good. What we'll do now is we'll check another mode of rollback. Just first of all, we'll let's assume that this is the only change that was going to go in 110, and let's tag it with 110. So I'll go ahead and make the change in the file. So we already have the baseline tag. Change log. Okay, this is the SQL file. It's similar to what we have seen till now for 100. It's similar in nature. We just mentioned 110 tag. Okay, so package the SQL where we execute the package will be marked as 110, and a new entry will be created with the tag 110. Okay, now what we'll do is like what I wanted to cover was another mode of rollback, that is using the tags. You can roll back using the tags. So let's try to roll it back to 100 version. Yep. And so this is a little confusing because it says roll back 100, but it is not rolling back 100, but it is rolling back to 100. So that's what we'll see in the data changelog table. It should we should see only 7 rows. Yes. So we have the tag 100. So it rolled back till 100. So any changes after 100 were removed. So this is how the rollback works. This is a different mode of rollback. We can again go in, apply the update, and we'll see everything will appear back in the changelog. So what we'll do now is we'll this is how these are basic functionalities of Liquibase, which we'll use regularly or normally. There is one more functionality of Liquibase, which is generate changelog. What it does is it basically generates all the change sets which we had applied over a period of time. It will generate a single changelog for all of them. This is it depends on project to project if this comes in helpful or not. But if someone wants to create the entire schema, as we are referring to right now, like LB demo user, if you have the entire changelog file, it will be really easy to create exact same schema as we have right now on another database or another schema. So let's try that quickly. So what we'll first do is like we'll rename the original changelog, since this command will generate a changelog. Yep, so generate a changelog. If we see this, it has created sequences which we already had, employee ID and departments. It has created the tables, departments, and employees, and any primary key or indexes we had. All of that has been created. What it has not created is package, because it does not have support for that. So packages are not taken care by the generate changelog command. So packages, triggers, functions, and procedures, these are not covered as part of changelog. So this needs to be taken care of when we are relying on the generate changelog command. This is something that is a limitation of Liquibase. The last thing which I wanted to cover was the diff command. I'll rename this back. So the reference parameters which we didn't go through earlier, these are used for diff command. So let's say if you want to compare our schema with a schema that is in the other environment, like a dev schema with a QA schema or QA with prod, the diff command comes in handy. What it does is it compares all the objects and sees if there are any changes between the schemas. So it will give you a list of changes. So we have, this is the reference schema for us. Mango QA is the same database, but it's a different schema. Here we have LB demo user, and here we have Mango demo prep user. So let's compare. Okay, it we can ignore the catalogs and the schema. I just compared the schema to schema and catalog. But apart from that, there are no changes we see between between these two schemas. If there had been, we could easily see it here. It is listed down here. And from that, this is particularly everything about diff. Yes, there is one more command to drop everything. So let's see. We want to drop all the objects that we created. So it will bring the database status back to where it was before we started using Liquibase. All the changes will be rolled back. Database log, as you can see, is no longer exists in no tables. These packages again are not taken care by the drop all, so it is still there. It needs to be dropped manually since packages are not supported by Liquibase. Apart from this, and if we just say, let's say update, it will bring back all the changes. Yes, everything is back. So that's pretty much what I wanted to cover today. It also has like one last thing. It has plugins for Ant and Maven, so it can be easily kicked off using Jenkins. So that's really handy. And yeah, so the next thing which I'm going to work on is to integrate this with Jenkins, and that's a small part of it. Apart from that, yes, that's pretty much I wanted to cover today. And thank you everyone, and have a nice day ahead.